Hello, everybody. Welcome back to my series on building an HTTP server from scratch in Golang. Um, Last episode, we implemented a little parser that parses a request and extracts useful information out of it, like the method, the route, the version, the headers. And today, our goal is to build a request response builder. So at the end of the video, we want to be able to respond to our client, our web browser in particular. And our response will just be a hello world string. So if everything works, our browser will display hello world. But the foundation for more complex responses are laid then, because then our server can form a valid response in HTTP format. If we have a look what we've done so far, we start our server, are ready to accept connections. Where's our second terminal? And just perform another curl. And as you can see, there's some debug statements in the code, but that's not too bad. We extract the method, which is get. The path is just slash, so just an empty path. We could also like specify, say, slash users, and then we will see that the path is users. The version is HTTP version 1.1. The headers are the accept header. The host is localhost, and user agent is curl. Wonderful. If we go back to our wonderful RFC of the HTTP protocol and we go to chapter 6, the header is response. That's what we need today. Like the request in episode 2, it is built in a similar way. We have a status line, and the status line has a prefix of the HTTP version, space, status code. If we successfully handled the request, the status code would be 200, meaning okay. And then another space, a reason phrase, and a new line character. The question is what the reason phrase is. But let's first have a look at the status codes that are available to us. Everything starting with a 1 is informational. I've never seen this in action, actually. Request received continuing process. I've never seen a web server sending that to a client. Maybe it's under the hood and you don't see it as a user. Possible. Everything starting with 2 is very nice because that means success. Everything with a 3 beginning is category redirection, meaning, for example, server is at a new place and I will redirect you to the new server or give you the new address. Everything starting with a 4 is a client error, like bad request. 404 is probably the most famous one, page not found, meaning the resource requested does not exist on the server. And there are 500 status codes as well, meaning server error, which means you as a client did everything right, but there was an error on the server, and that usually means you cannot do anything except for maybe try refreshing the page and hope that it's no error then. Let's continue to the reason. What was it called? the reason phrase. The reason phrase is intended to give a short textual description of the status code. The status code is intended for use by automata, and the reason phrase is intended for the human user. Okay. I know that the status code 200 has the reason phrase okay in uppercase letters, so we will do that. Let me think. Let's put this on the side, and I think we will not need this. So I've outsourced the things we did last episode, the HTTP requests, into a separate package, just to like have a cleaner main. We will not need this debugging shit anymore. Don't need this. Don't need this, and don't need this whole new line, because we know it works. And I already created a file called response, which will have an HTTP response struct. So what do we need? Our response. Why are we in chapter 8? Our response definitely will need. Yes, a good question. Do we like have an field status line, a map of headers, and a body? Would be logical, right? We could also like have a field, a member for like the version, but I think the most clean way is to actually, that's a good question. Do we even need a struct for our simple case? We could also say it's just a string with the message, which obviously go written this way, and a couple of functions that build it. Yes, I think I'm a big friend of keeping things as simple as possible. And in our case, it will just be a string, an HTTP string at the end. But we will need we could. Or can we? How do we call the actual response data? I think data would be fine, right? And for now, the data will be the hello world string, and then we like need functions for response, build status line. We need the version. We need the. Okay, so we should also pass the request here and take this as an input, because it holds information we need for the response, like the version, for example. Yes, and this returns a string because our HTTP response is string, and then in this function we will have like string status line, a string blah, and then concatenate them at the end, right? For now, return. No, it's not allowed, right? We just return an empty string for now. Then we need the headers. Response. TP response. Build header string. What do we need here actually? We need the data because one of the headers we definitely will need is the content length. I don't know if it's under response headers, general headers, or entity headers. I think it was under entity headers. Exactly, content length is something we need for sure. Because I think our browser needs it to be able to know what to display. Content length is a key value string. We will have the content length word, then we have a column, and then one time digit. And I think a digit will probably be just a digit. Not too hard to guess. And decimal number of octets sent to recipient, or in the case of the head method, the size of the entity body that would have been sent had the request been a get. Okay. Yeah, okay. We just have a decimal number here. Perfect. That's good to know. What does this method return? Another string, I guess. And let's say for now we return. We will have like an content length. There's one more thing I will have to look up. Let's say it's 100 for now. And then this needs to be converted to string, content length string. And I think we need this string int don't we? Maybe not. Can we just say string content length? We did not define it. We can, the question is, and we'll test this in the main. My question is, I think there's a better way to test this. My question is, what actually the string contains when we type in string 100. Let's run it. An error, perfect. Conversion from untyped into a string yields a string of one row, not a string of digit. Exactly, that's what I thought. Into string conversion. As you can see, not the first time Googling this. And will definitely not be the last time, I can promise you that. Stringconf.atoy. But that's the wrong way. No, we want the other way, please. Iota. Ah, yes. And I've read about where this comes from because in my work, I at the moment program in C++, and I also use the iota function today. And I was wondering, but iota is the character, Greek character, I think. Iota character. Yes, of the Greek alphabet, and is usually used as a indice in mathematical formulas, apparently. But that's yeah, drifting away from the topic. Is it possible to call in this iota 100 on the server to test it? No, okay. No problem for us. So we have content length, like we used to have, let's say 100. Then we will have a string of that by string conf iota, there it was. And we pass in our variable, obviously. And then we return, it's called as result is, and then we not need our RC again with the entity header. And we know that we will have content length followed by the column, no space, content length string. And then we log this one, header string, because I want to see if Go puts a space in between. That would be a problem for us. We return the result here. Later on, if we need more than just this header, just one header, then we need another data structure, not a string. But we still return a string, but we would need a map for all headers, and we would also need a request. No, we don't need to request then, but we would need a map of all headers and yeah, put them in one string separated by a new line character. The header string actually needs to be to end with a new line character. Correct? But let's first check what the actual number of the content length mean, because is it the number of bytes our data contains? Is it the number of characters? I would think it's the number of bytes. Let's check. Indicates the size of the entity body in decimal center recipient, or in the case of yes, size of the body is leaves room for interpretation. Okay, sounds for me like bytes, but it's actually not specified in the RFC. That is interesting. Okay, let's check wire group content length, header size in bytes or number of characters in bytes of the message sent. Yes, that makes the most sense. Okay, so we need to extract the number of bytes this string contains to actually calculate the context length. We'll do that next. But what I wanted to see is, yes, exactly, do we need two new line? I think so, right? We would need two new line characters at the end because the first one, in this case, marks the end of this header, this specific header line, but there can be any number of headers, and the end of all headers is indicated by another new line character, followed by the message body, which will be our data. And now we would need a function, func get byte count of string. Any string is any legit. I don't think data. Let's call it data string, and it can actually just return an integer. Return 0. I always don't like the red marking, so I eliminate them. Okay, how do we get? I know that a string in Go, the data structure, consists of 2 bytes. The first byte is the size of our string in bytes, I think in bytes, and then the second is a pointer to where our actual data starts in the memory. And because we know the amount of bytes, we also know where it ends. So it's not like in C, for example, a string is just 8. Or yes, it's just 8 bytes. It's a character array. It's just a pointer to the first element of this array, and the last element always has to be a null character. And this indicates that the string is over. Yes, but in Go it's not. Go string access first byte access count of bytes. Okay, apparently the lang method returns the number of bytes in the string. We print the bytes in the string hello string by looping through the string using lang method. The lang method returns the number of bytes in the string. We then use the returned number to loop through the string and access the bytes at each index. Okay. But shouldn't it be more simple if a string always holds the number of bytes in its metadata? Maybe those are accessed by the lang function, actually. Okay, there's some unsafe pointer thing going on. I don't want to understand. Okay, let's we don't need a function for that, obviously. This would mean data. This would mean it would be that simple. Can we have a look at the implementation? Not really. This looks like an interface because there's no function body. Is there any way to go to implementation? G, Shift I. But this leads nowhere. Okay. But according to its type, there is no string here as an example. But let's just assume it works. Or, you know what? Let's test it, right? Length of the string hello should yield 5. I mean, this would be true for 5 characters and 5 bytes, but never mind. Where is our error? There's a parentheses missing 5. Okay, if we type hello, that's the 6th character. World is also 5, so we are at 11, and now we are at 12, probably. Yes, the math of mathing. Okay, we should be able to use this. Okay, perfect. Now we have our response for our header string. That is wonderful and lovely. We need our status line, and then we are actually good to go, I think. Okay. What are we doing here in our status line? We need the HTTP version space, status code space, reason phrase. Okay. Status code and reason phrase will be hard coded for now because I can. Status code will be 200. Reason phrase will be okay. And then we need to convert it to a string again, and we'll do it this way because then we will be able to replace the 200 with a variable later on. If we would like just type in the string, it's hard-coded, this would not be possible. Okay, we have status code and we have a reason phrase. Only thing we're missing is the request dot method. No, version. Fuck. What did we actually it's still opened? Yes. Okay, the version contains the full version string. That's good. Not just a number, because I think we need the full version string again. Then we can return. Okay, let's form a result string. And then we return result here. And this contains request.version plus space plus status code plus space plus reason phrase plus new line character at the end here, at the end of the status line. Then we say status line equals to build status line. Which takes our request parameter. Then we header string. Build header string, takes our data, and our body consists only the full data. And then we return. We actually have to check if the body does not need a new line character, because we have the content length and our browser knows where the end is. Nice. Perfect. This means you just have to concatenate everything and hoping that concatenation works this way in go too many return values. Ah, yes, because we did not actually. Attaching it to a string does not make any sense, right? No, no, no. We will do not do that. And this method, by the way, needs to be public, so someone outside of this package will be able to call it. Actually, let's capitalize this as well to make it public. And then let's put this here. That's fine for now. And then we don't need this here and this here, and just don't attach them to anything as well. Yeah, that does only make sense for structs, I think, to attach functions to a data type. But now we actually get an error. Cannot use value of type string as. But why? It is string, right? Or do we need to say response equals to HTTP response? What if we say var response is of type HTTP response, and then we say response equals to the shit here? Will probably yield the same error actually. Let's check. And we also opened shit we don't want to open. Yes, probably yes. I cannot use incompatible assign. Okay. I mean, we don't really need this. Just looks prettier, actually. But fuck it, will only cost us time. Then we can delete this whole thingy and just return the respawn, which is a response, obviously, and our function needs to return something. We deleted this. Okay. Let's have a check at the time. 32 minutes already, holy moly. But I think the good news is that if we go into our main Go now, we are quite hopeful that we are able to build a response. Let's say print line, building the response. Let's say response equals to, I think I still need to import it. Exactly. Web server is the underlying package. But because there's an error, it does not work. Oh, why does it not work? Model is already imported perfectly. Okay. Then, yes, the function is already here. Perfect. The data is hello world. Let's specify it here. Data. And then also our request as a reference. Yes, looks good to me. Should we print our response? Yes, we want to see it. Response. And then the next line is the actual where it actually starts. Response. And then con.write as in byte array, which is no problem for us, I think. Let's say we get back nothing and an error. And we will write as a byte slice our response, which needs normal parentheses, I think. Yes, that should work fine. If error equals no, log fatal. Error responding to client or something. So I'm really interested in what the difference is between error.error and just error. Because with the percentage %v, we can actually just return the error. Okay. Yes. Never mind. If someone knows, please put it in the comments down below. Okay, we now should be able to send a response to our client. Let's clear this. And we run our server again. Ready to accept connections. No error there. And then we just curl. Response HTTP 101 200. Okay, content length. Hello world. Is the no. That's the response string. The whole response string is this, with the empty line indicating the end of the headers. Should be fine. Maybe that's one too much. We will find out. But no, here is our response actually. Yes, perfect. Nice. That's a valid response, I think. And we should also see this if we request our server via the browser. Yes, there's hello world printed in our browser. That makes me very, very happy. And I don't know if you remember or if you watch, but in the first episode at the end, where we were able to accept a request and just print the request text to our console, we saw that we had like 9 requests or something, and this was because when we closed the TCP connection without responding to the client, our browser was like an annoying stalker and thought, what could be the reasons he's not answering me? It cannot be that he does not like me. It has to be because he has internet connections. So I will just perform another request. And it did this like 9, 10 times. And then gave up and said, okay, not possible. That's obviously very good mechanic in web browsers. But was confusing me at the time. And now, as I promised back then, we only have one request from the browser, and it's interesting to see that the path actually favicon.ico, because I think that's something out of cache, because at port 8080 I was hosting another small service I was implementing. As you can see, if I go back to the browser, where is it? There. And I type in localhost, you see this icon here, and I think this one, the request was cached, and the slash favicon was appended. If we like type in user, we still get the hello world because we don't support routing yet. We are not that modern. But there was a new connection. It was 5 bytes longer because there are actually exactly 5 characters more, and 1 character is 1 byte. And now the path is /users. That's very good. We have more headers than we had in the curl request. Um, there were some headers for the image format our browser expects or accepts. Um, um, that's not here anymore if we request users, but we have like the connection keep alive. We have the host. We have a different user agent. It's now a Mozilla browser again. And yes, actually, that's it for today's episode. Our goal is reached, and I don't think there's anything quick we can do in this episode, actually. Um, but there is a lot to come. Um, the next episode we will try to build a router, meaning that um, the path we request actually matters and hits different paths in our code. Um, we will also need like a map which paths are valid. So if we hit a valid path, we will return the same response as in this case, maybe say hello world at path and then append the path. And if we like hit a non-valid path, then we will return a 404. And yeah, we will return an error message to the client. Yes, we will. In a real web server, you would like have a handler for every route, which knows just a class that knows what to do if a specific route is hit. Um, and yeah, that's I think the goal for next episode. And then after that, we could implement concurrency. So our request handling does not limit to performing the handling in this loop, because what we did not test yet, maybe we can do that at the beginning of next episode, is what happens if we accept the connection we just sent, and while we are still handling the request, another request hits. My guess, we are in the code section here, and we are not waiting or not really listening to other requests. Maybe there's a queue implemented in the listener. That could be the case. Then we would probably there is a queue actually, and then this would mean that we would handle it just after we handled the last request. But maybe I don't think the server would crash. But yeah, we would like have a go routine, a pool of workers that are able to handle our requests, and so we can handle multiple requests at the same time. This will be another big episode, and then the last episode would be the sixth. And I think the goal for that would be to um, deliver files to the client, like an HTML file or an image, which is requested by the user in at a specific route, at a specific path. I mean, there are a lot of things a web server still needs, right? We would need a rate limit, so a user can only request a specified amount of requests in a given time. we would need authorization, obviously. Is the user actually allowed to enter to access the resource the user's requesting, stuff like that. But this is not planned for now. I think 6 episodes is a good amount for a series like that. All right, enough talking. Thank you for listening, for watching, and I hope you learned something new. I hope you also find it exciting that we see Hello World here on the screen. And yes, I hope you tune in the next episode, and I'm looking forward to it. And I wish you a good time.